When installing a temporary 480-volt, 200-amp three-phase power feed between two wood poles, several key components and considerations come into play. This setup involves 3 hot wires and a combined messenger and ground wire, and the proper selection of hardware and adherence to the National Electrical Code are essential for safe and compliant installation. Firstly, the messenger clamp is a critical component. This wedge-like clamp is designed to grip the messenger cable securely, providing the necessary support and tension for the overhead conductors. Common names for this type of clamp include messenger clamp. Some prominent manufacturers of messenger clamps include Burndy, Titan, and Jocelyn. These manufacturers offer a range of clamps designed to accommodate various cable sizes and load requirements. Secondly, the appropriate cable type is crucial. A suitable option for this application is triplex service drop cable. This cable typically consists of 3 insulated conductors for the hot wires and a bare messenger/ground wire. The messenger wire serves a dual purpose, providing mechanical support for the cable span and acting as a ground conductor. When selecting triplex cable, ensure that it is rated for the appropriate voltage and amperage, and that the conductor sizes are adequate for the load requirement. Thirdly, determining the correct ampacity table is vital for ensuring that the conductors are adequately sized to carry the intended current without overheating. For overhead conductors in open air with a wind velocity of 5 meters per second, refer to the National Electrical Code Table 310.15. B16. This table provides ampacity values for various conductor sizes and insulation types under specific conditions. Alternatively, you can use the following approximate ampacity values for a 480-volt three-phase system. For a 3/0 American wire gauge conductor, the approximate ampacity is 180 amps. For a 4/0 American wire gauge conductor, the approximate ampacity is 215 amps. These values are intended as guidelines, and it is always recommended to consult the NEC table for accurate and up-to-date information. When installing the temporary power feed, adhere to all applicable safety regulations and best practices. Use appropriately rated hardware and tools, and ensure that all connections are secure and properly insulated. Ground the messenger wire effectively to provide a safe path for fault currents. Furthermore, consider the environmental conditions in the area where the temporary power feed is being installed. Factors such as wind speed, temperature, and exposure to sunlight can affect the ampacity of the conductors. Adjust the conductor size accordingly to account for these factors and maintain a safe operating temperature. In addition to the messenger clamp, cable type, and ampacity table, other important considerations include the selection of appropriate insulators, hardware, and grounding equipment. Ensure that all components are compatible with the voltage and amperage of the system, and that they are installed according to the manufacturer's instructions and applicable codes. Before energizing the temporary power feed, thoroughly inspect the entire installation to ensure that all connections are secure, all components are properly grounded, and that there are no exposed conductors or other potential hazards. Use a voltmeter and ammeter to verify that the voltage and current levels are within acceptable limit. If any problems are detected, correct them immediately before proceeding. Regularly inspect the temporary power feed throughout its service life to identify any signs of wear, damage, or deterioration. Replace any damaged or worn components promptly to maintain the safety and reliability of the system. When the temporary power feed is no longer needed, de-energize it properly and remove all components in a safe and orderly manner. Dispose of any waste materials in accordance with applicable environmental regulations. Remember that working with electricity can be dangerous, and it is always recommended to consult with a qualified electrician or electrical engineer if you have any questions or concerns. By following these guidelines and adhering to all applicable codes and regulations, you can ensure safe and reliable installation of a temporary 480-volt, 200-amp three-phase power feed. Understanding the function and selection of messenger clamps, the appropriate cable type, and the correct ampacity table are essential for this task. Always prioritize safety and consult with qualified professionals when necessary. Furthermore, consider the long-term implications of temporary power installations. While they provide a convenient solution for short-term power needs, they may not be suitable for permanent applications. If long-term power is required, consider installing a permanent electrical service that meets all applicable codes and regulations. This will ensure a safe, reliable, and code-compliant power supply for the long term. In the context of temporary power feeds, it's important to differentiate between various cable types and their applications. Triplex service drop cable, as mentioned earlier, is commonly used for overhead service drops from the utility pole to the building. However, other cable types, such as underground feeder cable, may be more suitable for underground installations. When selecting a cable type, consider the environmental conditions, the installation method, and the load requirements. Also, be aware of the different insulation types available for electrical cables. Common insulation types include THHN, THWN, and XHHW. Each insulation type has different temperature ratings and resistance to moisture, chemicals, and abrasion. Select the appropriate insulation type based on the specific application and environmental conditions. In addition to the ampacity table and the NEC, other resources can provide guidance on conductor sizing and ampacity. These resources include manufacturers' catalogs, industry standards, and engineering handbooks. Consult these resources to ensure that the conductors are adequately sized for the intended application. Also, be aware of the dating factors that may apply to conductors in certain conditions. Dating factors are used to reduce the ampacity of conductors that are installed in hot environments, bundled together, or run through conduit. Apply the appropriate dating factors to ensure that the conductors are not overloaded. When installing overhead conductors, maintain adequate clearance from the ground, buildings, and other structures. The NEC specifies minimum clearance requirements for overhead conductors based on voltage and location. Adhere to these clearance requirements to prevent accidental contact with the conductors. Also, consider the potential for ice and snow accumulation on the overhead conductors. Ice and snow can add significant weight to the conductors, which can increase the tension on the messenger cable and supporting structures. Design the installation to withstand the expected ice and snow loads in the area. When working with electrical equipment, always wear appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. Follow all lockout/tag-up procedures to prevent accidental energization of the equipment. And never work on live electrical circuits unless you are properly trained and qualified to do so. Grounding is an essential aspect of electrical safety. A properly grounded electrical system provides a safe path for fault currents to flow back to the source, which helps to prevent electrical shock hazards. Ensure that the messenger wire is properly grounded at both ends of the span and at any intermediate support points. Use appropriately sized grounding conductors and connectors, and follow all applicable grounding requirements in the NEC. Surge protection is another important consideration for electrical systems. Surges can damage sensitive electronic equipment and cause fires. Install surge protective devices at the service entrance and at any critical equipment locations to protect against voltage surges. The NEC contains specific requirements for surge protection in different types of electrical systems. Regular maintenance is essential for ensuring the continued safety and reliability of electrical systems. Inspect the temporary power feed regularly for any signs of wear, damage, or deterioration. Tighten any loose connections, replace any damaged components, and clean any accumulated dirt or debris. Keep the area around the temporary power feed clear of vegetation and other obstructions. And if you ever have any questions or concerns about the safety or performance of the electrical system, consult with a qualified electrician or electrical engineer. They can provide expert advice and assistance to ensure that the electrical system is operating safely and efficiently. Always remember that electrical safety is everyone's responsibility. By following these guidelines and adhering to all applicable codes and regulations, you can help to prevent electrical accidents and injuries. In addition to the technical aspects of installing a temporary 480-volt power feed, it's important to consider the permitting and inspection requirements in your local jurisdiction. Many jurisdictions require permits for electrical installations, including temporary power feeds. Obtain the necessary permits before starting any work and schedule an inspection by a qualified electrical inspector to ensure that the installation meets all applicable codes and regulations. The electrical inspector will typically review the plans, inspect the installation, and conduct tests to verify that the system is safe and code compliant. If any deficiencies are found, they must be corrected before the system can be energized. Cooperate fully with the electrical inspector and address any concerns promptly. Also, be aware of any restrictions on the use of temporary power feeds in your area. Some jurisdictions may have limits on the duration of temporary power installations or restrictions on the types of loads that can be connected to a temporary power feed. Check with your local authorities to ensure that you are in compliance with all applicable regulations. In some cases, it may be necessary to install a permanent electrical service instead of a temporary power feed. A permanent electrical service provides a more reliable and long-lasting power supply, and it is typically required for permanent buildings and structures. If you are unsure whether a temporary power feed is appropriate for your needs, consult with a qualified electrician or electrical engineer. They can assess your power requirements and recommend the best solution for your situation. In addition to the technical and regulatory aspects of electrical installations, it's important to consider the environmental impact. Electrical systems can consume significant amounts of energy, which can contribute to greenhouse gas emissions and climate change. To reduce the environmental impact of electrical systems, consider using energy-efficient equipment and practices. Use LED lighting instead of incandescent or fluorescent lighting. Install energy-efficient appliances and equipment. And implement energy-saving measures, such as turning off lights when they are not needed and unplugging electronic devices when they are not in use. Also, consider using renewable energy sources, such as solar panels or wind turbines, to generate electricity. Renewable energy sources can reduce your reliance on fossil fuels and lower your carbon footprint. Another important aspect of electrical safety is arc flash protection. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flash can cause serious burns, injuries, and even death. To protect against arc flash hazards, conduct an arc flash hazard analysis to determine the potential arc flash energy levels in the electrical system. Use appropriate personal protective equipment, such as arc-rated clothing and face shields, when working on or near energized electrical equipment. And follow all arc flash safety procedures to minimize the risk of arc flash injuries. The National Fire Protection Association Standard 70. He provides detailed guidance on arc flash safety. This standard covers the requirements for arc flash hazard analysis, personal protective equipment, and work practices. Familiarize yourself with the requirements of NFPA 70 and implement them in your workplace to protect against arc flash hazards. Training is essential for all personnel who work on or near electrical equipment. Provide regular training on electrical safety, arc flash hazards, and safe work practices. Ensure that all personnel are properly trained and qualified to perform the tasks they are assigned. And never allow untrained or unqualified personnel to work on or near energized electrical equipment. Finally, remember that electrical safety is an ongoing process. Stay informed about the latest codes, standards, and best practices. Regularly review your electrical safety program and make any necessary improvements. And always prioritize safety in all of your electrical work. By following these guidelines and adhering to all applicable codes and regulations, you can help to prevent electrical accidents and injuries and ensure the safe and reliable operation of electrical systems.